Okay, today we're going to be learning about several types of triangles. The first type of triangle that we're going to learn is called an equilateral triangle. This means that all sides are equal and all of the angles are equal. All of the angles equal 60 degrees. And an isosceles triangle has two equal angles, and it has two sides that are both the same length. A scalene triangle is a triangle where the angles are always different degrees. Okay? There's no equal sides and no equal angles. Now if we look at this triangle, what type of triangle do you think this is? Is it an equilateral triangle, an isosceles triangle, or a scalene triangle?
Well, it looks like an
Equilateral.
It looks like an equilateral triangle.
That's right, because it has three equal sides and it has three equal angles that always equal 60 degrees. This triangle, let's look at the vertices here, okay? We have two vertices that are both 67 degrees. So what type of triangle do you think this is? An equilateral triangle, an isosceles triangle, or a scalene triangle?
It looks like a scalene triangle.
Well, scalene triangle has no equal angles, okay? So it cannot be a scalene triangle because these two angles are exactly the same. Now let's look again, okay? An isosceles triangle has two equal sides, okay? And it has two equal angles. So if we were to label this as alpha, beta, and gamma, okay, both beta and gamma have the same angle of 67 degrees. So because it has the same angle on two vertices, this is an isosceles triangle. Now let's look at this. This triangle has two equal angles here on vertex B and here on vertex C. So because they have two equal angles, what type of triangle do you think this is? An equilateral triangle, an isosceles triangle, or a scalene triangle?
I think it's an isosceles triangle.
That is correct. It is an isosceles triangle. That is because it has two equal sides and two equal angles. On this triangle, let's see if we can identify this one. The first thing that we look for is the angles. Now in each angle we notice that they are completely different. None of them are the same. And also since none of the angles are exactly the same, it also means that the sides here are not the same distance. Okay. So what type of triangle do you think this is? An equilateral triangle, an isosceles triangle, or a scalene triangle?
It looks like a scalene triangle.
That is correct. It is a scalene triangle because it has no equal sides and no equal angles. Now we are going to look at a interactive example here. Can you notice that when we move this equilateral triangle around, okay, I'm just going to move one of the vertices, the angles always stay the same. They always stay at 60 degrees. And if you notice, every angle always adds up to 180 degrees. So it really doesn't matter in what direction or how we rotate this triangle, it will always stay the same angle here, with 60 degrees. An isosceles triangle has two equal sides and two equal angles. So if we notice that these 2 points here on vertice B and vertice C, as we move them, they stay exactly the same angle. However, this third angle with vertice A adjusts to accommodate the other two angles that are staying the same. Okay? And again, if you look at the bottom here, in this example, we see vertice A equals 88 degrees, vertice B is 46 degrees, and vertice C is also 46 degrees, which equals, if you add them up, they equal 180 degrees. With a scalene triangle always has angles that are completely different. And although they are completely different, because it's a triangle, all of the angles will always equal 180 degrees. So if you look at the bottom here, you'll notice that although I'm changing the position of the vertices, the triangles and then the angles always add up to the same 180 degrees. This will be a clue later for how we can find any missing angles as long as we have two angles, and then we can use it to find the third one. A right triangle is a triangle that always has a right angle. So vertices A will always be at 90 degrees. So if you notice, even though I am changing the other vertices, one angle always stays at 90 degrees. And if you look here at the bottom, pay attention how all of the angles always add up to 180. An acute triangle has angles that are always less than 90 degrees. So if you notice, as I adjust this, all of the vertices, the angles of the vertices will stay below 90 degrees. However, they still add up to 180 degrees. An obtuse triangle has an angle of more than 90 degrees. Okay, so let's pay attention to vertice A. And notice what happens when I try to move the two vertices close to one another. For example, vertex C, if I try to move it towards vertex B, vertex A continues to stay at 91 degrees. And again, pay attention to the fact that all of these angles always equal 180 degrees. So in your lesson today, in your lab, I want you to practice with this interactive triangle by visiting mathisfun.com with the link below, and practice adjusting these triangles. This is important for you to learn how to be able to identify these.